Hi students, welcome back to my channel Chemistry with Saranya ma'am. So here in the last video we have discussed about the molecular or postulates of molecular orbital theory, LCAO approach, and we have discussed the stabilities of hydrogen minus, and we have discussed the stabilities of H2 minus and H2 plus. So what is the stability order? So here it is H2, the stability order, we have discussed this one. Okay, now today in this video actually we'll continue with this molecular orbital theory. We'll discuss some more examples. Okay, helium 2. So helium atomic number Z is equal to 2. So 2 helium molecules. So how many electrons? 4 electrons. Okay. Atomic number is equal to number of protons, which is equal to number of electrons. So helium 2 containing 4 electrons. So first write down the electronic configuration first. Here what is the electronic configuration? It is 1s. It is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Okay, so this electronic configuration is for less than or equal to 14. If the number of electrons in a molecule are less than or equal to 14, then we will follow this electronic configuration. So less than 14, LP, I told you, no? So pi comes first. Pi 2px is equal to pi 2py. These two are degenerate. So after comes to sigma 2pz, and then anti-bonding orbitals of this pi star 2px is equal to pi star 2py, and again here sigma star 2pz. This is anti-bonding orbital of 2pz, sigma 2pz. This is the electronic configuration. Okay, now here write down the electronic configuration for this helium 2 and write down the energy level diagram. Okay, so here 4 electrons means here the electronic configuration is 1s2, sigma 1s2, sigma star 1s2. So what is the energy level diagram? Here is your helium 1, helium 2 containing 2 electrons, 2 atomic orbitals. Here what is the LCAO combination? Here each atomic, how the atomic orbitals are combined, this is very important. Here atomic orbitals are combined, means each atomic orbital is considered as a wave function. If they both are combined, combination of, you assume this is Xi1 and Xi2 of, this is helium 1 and it is helium 2. Here if they are in constructive interference, means here these two wave functions are added up. Here we'll get an atomic orbital which is which is having less energy than these atomic orbitals, and the another one with the higher energy than the atomic orbitals. So here this is the energy level diagram. So here 2 electrons. This is sigma 1s and it is sigma star 1s, anti-bonding orbitals. Now calculate the bond order. Bond order for helium, here it is the half of the difference between number of bonding minus number of anti-bonding electrons. So how many bonding electrons? Here 2 minus how many anti-bonding? 2. So altogether bond order 0. So here there is no bond between helium atoms. Okay, so there is no bond between helium 2 atoms, therefore which indicates that helium 2 does not exist. Okay, and next you write the electronic configuration for helium 2 plus, and write down the draw the energy level diagram. Helium 2 plus means total number of electrons minus 1, 4 minus 1, 3. So what is the energy level diagram? Here what is the electronic configuration? Sigma 1s2 and sigma star 1s1. So one helium atom, another helium atom, it is Xi1 and it is Xi2 of another helium atom. and here when these two are combined, here one orbital, one molecular orbital with energy lesser than the atomic orbitals formed, and another one will be formed with the energy greater than these atomic orbitals combined. So here what is the electronic configuration? It is helium plus 2 1 and electron in the one anti-bonding orbital. So this is sigma star 1s1 bonding. This is anti-bonding and it is sigma 1s2. Okay, this is the electronic configuration. Now you calculate the bond order for helium 2 plus. So what is the bond order? Bond order 1 by 2 is equal to number of bonding 2 minus anti-bonding 1, which is equal to 0.5. So here molecule exists, helium 2 plus. Now and here what is the magnetic nature? Here one unpaired electron is there. So helium 2 plus is paramagnetic. It is paramagnetic. Okay, this is about helium and helium 2 plus. Now I'll clear this one, and now you compare H2 minus. First you compare the stabilities of this H2 minus and helium 2 plus. Okay, compare the stabilities. Here this hydrogen 2 minus 1, 3 electrons. Minus means here you have to add minus means plus 1 to the number of electrons. Okay. Now what is the energy level diagram for this one? One hydrogen, Xy1 of H1, Xy2 of H2, and here 3 electrons, 1, 2, 1, 1, 2. So if you observe these two, this is sigma 1s2 and it is sigma star 1s1. If these calculate bond order is equal to half of the difference between number of bonding 2 minus 1, which is equal to 0.5. So one unpaired electron and it is also paramagnetic. So if you compare these two are having same bond order 0.5 and same electronic configurations, and these two are paramagnetic, and experimental evidences confirms that these two are having the similar stability, similar bond orders. So here these two species H2 minus and helium 2 plus are equally stable. Okay, clear? Then we'll move into the next one. Write the electronic configuration and energy level diagram for Be2, beryllium. It is atomic number Z, number of electrons 4, and 2 berylliums, 2 into 4, altogether 8 electrons. So write the electronic configuration: sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So here first calculate the bond order. Bond order is equal to half of the difference between number of bonding 4. Here these two are bonding, no? 4 minus anti-bonding 4, which is equal to 0. So bond order 0 indicates that like helium 2, beryllium Be2 also does not exist. Clear? Okay. Next one, lithium 2. So here lithium atomic number Z is equal to 3. So 2 3s are 6 electrons. Write down the electronic configuration: sigma 1s2, sigma star 1s2, sigma 2s2. So write down calculate the bond order. So here bond order is equal to 1 by 2 number of here. So here this electronic configuration can be written as K star, sigma 2s2. So here this K indicates that this K 1s2 shell. So if you write K instead of 1s2, that represents that K shell has completed. So K star, anti-bonding orbital of 1s2. So if you write instead of K and K dash, if you written, that can be omitted. That can be omitted means here if K and K star represents, these K shells are completely filled, and these can be omitted while representing the energy level diagram. Got my point? So here this can be represented as K star 1s 2s sigmas 2s2. So here now write down the energy level diagram for this Li2. This is for one Li, second one. Okay. Energy level diagram. This is Xi1, Xi2. This is, if they are added up, we get a bonding. Okay. 2s2. So K star can be omitted while representing the energy level diagram. So here Li2 means 2s2. One electron here, one electron here. So 1, 2. So now you calculate, this is sigma 2s and it is sigma star 2s. Clear? Calculate the bond order for this one. 1 by 2, number of bonding 2 minus 0, 2 by 2, which is equal to 1. Bond order 1 indicates that there is a single bond exists between lithium, between two lithium atoms there exists a single bond. Clear? Okay. Now calculate the magnetic what is the magnetic nature? Here magnetic nature means here there is no unpaired electron, it is diamagnetic. So Li2 with a bond order 1 and a diamagnetic property. Okay. Next you write down the electronic configuration and energy level diagram for carbon C2. C2. Okay. Carbon 6. So 2 carbons altogether. 2 into 6, 12 electrons. So write down the electronic configuration. Here only I'll write 1s2 sigma star 1s2, 2s2 sigma star 2s2, 8. So 1, 1, 1, 2, 2. So 1, 2, 3, 4, 5, 6. This is the electronic configuration for C2 molecule. Okay. Calculate the bond order. Bond order is equal to half of the difference between number of bonding and anti-bonding. So here I told you, no, if these two shells are completed, we can omit this one. So K, this is K star and this is also K star dash you write. Okay, you can omit these by calculating the bond order also. So here what is the 2px2 and is equal to, there is no change in the bond order if you omit this one. First you calculate by including them. So 1, 2, 3, 4. 4 2s are 8 minus. Here how many anti-bonding orbitals? 1, 2. 2 2s are 4. So 4 by 2, 2. It is very stable. Bond order 2 means it is very stable. Now you omit this K star dash, and by omitting this you calculate bond order. Bond order is equal to half of the difference between number of bonding and anti-bonding. How many bonding? 4 minus anti-bonding 0, no? So here 4 by 2, 2. Clear? So if these shells are filled, you can omit them in the while writing the energy level diagram and also while calculating the bond order. Okay. Now, what is the magnetic nature? If there is, look at the electronic configuration. Is there any unpaired electron? No. So it is diamagnetic and it is highly stable with a bond order 2 and a magnetic nature is diamagnetic. Okay, clear? Now you calculate for nitrogen, and for this nitrogen we'll write the energy level diagram also. Okay. So here 12, 13, 14. Okay. So calculate bond order first. Bond order 1 by 2, number of, you omit this one, and here it is 6 minus 0, it is 3. So bond order 3 means 3 bonds exist between two nitrogen atoms. Okay, which is highly stable nitrogen molecule. So what is the magnetic nature? There is no unpaired electron, so it is diamagnetic. Clear? Like this, easily you can calculate bond order if you omit these one. Number of bonding minus anti-bonding 0. By looking at the electronic configuration only, you will be able to say whether they are diamagnetic or paramagnetic and what will be the bond order. If you omit this one, this will be very easy. Okay. Now we'll write the electronic energy level diagram for this nitrogen. Okay. Write down. We'll start from this 2s2. And it is also 2s2. Here 2 electrons. Okay, this is one nitrogen 1, nitrogen 2. Okay, 1s2, 2s2, 2p3, no electronic configuration. Now here we'll write. Here this we have written here. Okay, 2s2, 2s2, 1s2, 2s2, 2p3. Now electronic configuration of nitrogen. So these two are combining, forming sigma 2s2 and sigma star 2s2. Got it? So sigma 1s2, sigma star 1s2 we have omitted. And next here, so here I'll write the continuation of this electronic configuration sigma 2pz, and here it is pi 2px is equal to pi 2py and sigma 2pz star. This is the electronic configuration. Now here these are 1, 2, 3, 2p3, no? 1, so we'll write the reverse spin just for our convenience. Okay. So here next comes to here sigma 2s2, sigma star 2s2. Next should be pi 2px is equal to pi 2py. And then sigma 2pz. Okay, this should be okay, 3 electrons. Next comes to, this is pi 2px is equal to pi 2py, and here next 2pz, this is energy axis. Next comes to sigma 2pz, this is sigma 2pz. Next pi 2px is equal to, this is pi 2px is equal to pi 2py, antibonding orbitals. Next one, sigma star 2pz. This is sigma star 2pz. So if you look at the energy level diagram, here I have omitted 1s2, this one k dash, and next I have written the complete electronic configuration. So here what is the electronic configuration of nitrogen? 1s2, 2s2, 2p3. Similarly 1s2, 2s2, 2p3. So for 2s2, 2 electrons of one nitrogen, Xi1 and Xi2, here also, here they are, if they are added up, we get a bonding molecular orbital and anti-bonding molecular orbital. One with less energy, the same concept, and 2 electrons, electrons are filled. And here after that, next one, this we have done, and next comes to here, here it is 2p3, no, energy level. So p here, this is also 2p3 of another nitrogen. They combine to form the molecular orbitals. Here 1, 2, 3, 4. 1, 2, 3, 4. Okay. And next comes to sigma 2pz2. Here also. Altogether we have completed our electronic configuration. This is the energy level diagram. If you remember this electronic configuration, you can easily write down energy level diagram. This is for nitrogen. Okay. And next you calculate bond order for N2 plus and N2 minus. And explain the stability. N2 plus means here, N2 plus means here 14 minus 1, 13 electrons. So same energy level diagram. So from this one, I will remove this one. So here calculate the bond order. If I remove one electron from this one, altogether here how many? 5. 1 by 2, 5 minus 0 by 2, 2.5 is the bond order for N2 plus. N2 minus means here there should be, N2 minus means 1 electron in the anti-bonding orbital. Here this is the electronic configuration for N2 minus. Means here 14 plus 1 means 15 electrons. So here 15 electrons means 1 electron in the anti-bonding. So bonding it is 1 by 2, 6 minus 1, which is equal to 5 by 2, 2.5. So now compare the stabilities of this N2 plus and N2 minus. Both are having same bond order. So the stability, both will have the same stability. Here this is N2 plus is formed by the loss of one electron. So here for N2 plus it is paramagnetic, one unpaired electron, and here also it is also paramagnetic, one unpaired. Both are paramagnetic. Both are paramagnetic and both are equally stable. Okay, clear? I'll clear this one. Now next you calculate for N2 2 minus. Here N2 2 minus is formed by adding 2 electrons to nitrogen, N2, so altogether 16 electrons. You write down the, now the electronic configuration becomes, here it is till now 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. And these two are equally degenerate, no? We have to follow those rules. Now 16 means here, what will be the bond order? 1 by 2. How many bonding? Here 1, 2, 3. 3 2s are 6 minus here 2 anti-bonding. So which is equal to 4 by 2? 2. So bond order is 2. Bond order of 3. This is for nitrogen, and which is diamagnetic, and these two are paramagnetic, and it is also paramagnetic because it contains unpaired electrons. No. Now you write down the stability order. Now compare the stabilities of these nitrogens. So here first comes to nitrogen with a bond order of 3. Next comes to N2 plus, which is equal to N2 minus. After that N2 2 minus. This is the stability order. Now what is the bond length of this species? So bond length and bond order are inversely proportional. So bond length, if bond length is more, bond length is, if bond order is more, bond length is small. So here reverse this order. N2 2 minus greater than N2 minus equal to N2 plus than nitrogen. Okay. Many have confusion that here I have given two electronic configurations. No, if the electron, if total number of electrons are less than or equal to 14, you adopt this electronic configuration. But if you compare this one, N2 minus 14 plus 1, 15 electrons. So whether to follow this electronic configuration or the other one. But here this N2 minus comes from what is the parent atom? It is nitrogen, no? So nitrogen total 14 electrons. So whether it is N2 minus or N2 2 minus, you should follow this configuration because the parent atom, this is obtained from the parent atom nitrogen, no? Okay. So this is the stability order and it is the bond length. Okay. This is for today. And in the next video, we'll discuss previous year JEE questions. Till then, bye.